so far. By now, you know a bit more about Python syntax, about if, elif, and else statements, and about functions. In this section, we'll cover an important topic for Python programming: lists. So, what is a list? So, a new name, Dwayne, needs to be added to the participants list, and we'll use a method called append. Think of the terms method and function as interchangeable, because in practice, methods work quite like functions. However, the technically correct term to use in this situation is method. Here is the syntax that allows you to call ready-made built-in methods that you do not have to create on your own, and can be used in Python directly. After the name of the object, which in this case is the participants list, we'll put a dot called a dot operator. The dot operator allows you to call in or invoke a certain method. To call the method append, state its name, followed by parentheses. To insert the name Dwayne in our list, we must put the string Dwayne in inverted commas between the parentheses. After we execute the cell, we should have Dwayne added to our group. Shift and Enter. Correct. Great. Remember this general structure because we have to comply with it if we wish to call any existing method in Python. Alternatively, the same result can be achieved by using the extend method. Let's invite George and Catherine in our group. First, let's invoke the extend method. Okay, good. This time, within the parentheses, we'll have to add brackets, as we are going to extend the participants list by adding a list specified precisely in these parentheses. Execute through Shift and Enter, and you'll have the two pieces attached: the initial participants list and the extension. Thus, you still manage to enlarge your original list, right? A couple more things before we close this lesson. First, let me show you that lists' elements are directly treated as string values. After printing this command, we can see the first participant in our list is John. It was not necessary to put any quotation marks around the participants element to do that. Perfect. Finally, the len built-in function counts the number of elements in an object. For instance, if our word is dolphin, this function tells us it is composed of 7 letters. More importantly, though, this same function can be applied for obtaining the number of elements in a list. Applied to the list we have here, it shows us the list entails 6 members. Awesome! To summarize, observe how a built-in function takes the object participants as an argument, while when we are calling built-in methods, they are applied to the participants list with the help of the dot operator. The different syntax helps you distinguish between the two. By the way, lists can be sliced too, but more on that in our next video. Thanks for watching. In this lesson, we'll introduce you to another very important concept: slicing. In the future, when working in Python, you'll typically have to deal with data that is quite big. Many of the problems that must be solved will regard a tiny portion of the data, and in such cases, you can apply slicing. Imagine you want to use the participants list we saw earlier to obtain a second much smaller list that contains only 2 names, Leela and Maria. In Pythonic, that would mean to extract the elements from the first and second position. To access these elements, we will open square brackets, just as we did with indexing, and write 1:3. The first number corresponds precisely to the first position of interest, while the second number is 1 position above the last position we need. In our case, 2 plus 1 equals 3. Correct. We can say we just sliced our participants list to obtain a new one with the names Leela and Maria. I know this piece of syntax seems a bit strange, but it is not that illogical. Let's get the first 2 names from the list, John and Leela. In this case, you don't need a number at the beginning, and you can start by typing a colon. Okay, so by typing :2, we get exactly the first two elements. Very good. And how can I obtain the last two? One way would be to indicate the fourth position, corresponding to George, and leaving nothing after the colon. This would mean we will extract all the elements from the fourth position included to the end of our list. Another way to obtain the same result would be to put a minus sign in front of the number 2. Thus, Python will revert the direction of counting, starting from the end towards the beginning. How many elements are we asking for? 2. Let's execute. And here's the output. We've obtained George and Catherine in a new list. Perfect. Okay, let's check out some additional methods that can be applied to lists. Assume you know Maria is in your list, but you don't know her position. In other words, you'd like to obtain the index of the element Maria from the participants list. Just call the index method and indicate the string variable of interest in parentheses. The machine tells us Maria is in the second position. And it is. The next functionality is an interesting one. I will show you it is possible to create a list of lists. My goal will be to create a list called Bigger List, which contains the participants list, and a new one I will call Newcomers. Let the latter enclose the names of Joshua and Brittany. Shift and Enter. Okay, we created Newcomers. All I need to do in the next cell is write the name of the variable Bigger List and cite within brackets the names of the lists I would like to include. Let's verify if this works. Yes, it does. The two lists are shown in the suggested order. Great! An important method that could order the names of your participants in alphabetical order is sort. As you can see, after applying it to our list, Catherine comes first and Peter is last. If within the brackets we say we would like the names to be sorted in a reversed order by stating reverse equals true, Peter would be first and Catherine last. Naturally, if our elements were sheer numbers instead of people's names, this method would function without any problems. Observe how, in this example, I sorted the numbers from 1 to 5 from the smallest to the largest. And here, from the largest to the smallest. Wonderful! This was a very important lecture. Stay tuned for the next one, where we will discover what is a tuple. Tuples are another type of data sequences, but differently to lists, they are immutable. Tuples cannot be changed or modified. You cannot append or delete elements. The syntax that indicates you are having a tuple and not a list is that the tuple's elements are placed within parentheses and not brackets. By the way, the tuple is the default sequence type in Python. So if I enlist 3 values here, the computer will perceive the new variable as a tuple. We could also say the 3 values will be packed into a tuple. For the same reason, we can assign a number of values to the same number of variables. Do you remember we went through that a few lectures ago? On the left side of the equality sign, we just added a tuple of variables, and on the right, a tuple of values. That's why the relevant technical term for this activity is tuple assignment. In the same way we did for lists, we can index values by indicating their position in brackets. That's why we obtained the first number from the tuple x, namely 40. In addition, we can also place tuples within lists, and then each tuple becomes a separate element within the list. Tuples are similar to lists, but there are some subtle differences we should not overlook. They can be quite useful when dealing with different comma-separated values. For example, if we have age and years of school as variables, and I have the respective numbers in a string format, separated by a comma, hence the name, comma-separated values, the split method with the proper indication within the parentheses will assign 30 as a value for age and 17 as a value for years of school. We can print the two variables separately to check the outcome. Everything seems to be correct. Awesome! Last, functions can provide tuples as return values. This is useful because a function, which can only return a single value otherwise, can produce a tuple holding multiple values. Check this code. I will input only the length of the side of a square, and as an output, the squareInfo function will return a tuple. The tuple will tell me the area and the perimeter of the square. This is how we can work with tuples in Python. Thanks for watching. Now that you know what lists and tuples are, you will more quickly understand what dictionaries are about. Dictionaries represent another way of storing data. Each value is associated with a certain key. More precisely, a key and its respective value form a key-value pair. In this example, we have 4 keys. Different names of animals are attached to each one of them. Pay attention that neither parentheses nor brackets will work in this case. You need curly braces. After a certain dictionary has been created, a value can be accessed by its key, instead of its index. K1 can be used for cat, while K3, a mouse. Similarly, as we could do with lists, we could add a new value to the dictionary in the following way. The structure to apply here is dictionary name, new key name within brackets, equality sign, and the name of the new value. The value we'll assign to key number 5 is parrot. I'll press Shift plus Enter and we are good to go. Replacing a value follows the same syntax. Just let the new variable correspond to an existing key. From that moment on, attached to the second key, we won't see a dog anymore. Ha! It's a squirrel now! You feel a list should be able to take part in a key-value pair. And you are right. Let's turn to another example. Say, only Peter works in Department 1, but 3 people work in Department 2, Jennifer, Michael, and Tommy. Shall we verify? Right. Therefore, our second element is a list. There is another way to fill in a dictionary. I'll create a new variable and we'll use empty curly braces to indicate it'll be a dictionary. I will not place any keys or values within the braces. Instead, I will assign the keys and the values one by one. And, at the end, my dictionary will be full. Quite nice. And if I asked for the center, I will see Hector's name. Let me introduce you to an interesting Python feature. If the get method gives us the name of the small forward of a given team, the machine won't display an error if we ask for the name of the coach, whose name does not take part in my dictionary. None is the default value Python returns in cases where an object does not actually exist within a given dictionary. Now,
You can imagine that dictionaries could do a great job, sometimes. For instance, when using companies' names as keys and their prices on the market as values, right? Bravo! You are going deeper into programming. Remember, things will remain quite abstract unless you take the time to practice and apply what you've learned in these lessons. So, roll up your sleeves and do the exercises attached to this lesson. Thanks for watching. Iteration is a fundamental building block of all programs. It is the ability to execute a certain code repeatedly. In this section, we will focus on a few examples of iteration processes in Python. To begin, we have prepared a list called even. It contains all the even numbers from 0 to 20. Imagine we want these numbers printed out, so we can write the following. For in and even, colon, which would mean for every element in the list even, do the following. Print that element. In this case, in is called the loop variable. It is not required to have called it in. Any other name would have worked fine.
The phrase print, open parentheses, in, close parentheses, acts as the body of our loop. Don't forget, it should be indented to run the loop properly. The operation in the loop body is performed once for each element in the even list. Now, let's go over the steps implied by this piece of code. The loop starts by taking an element in from our list. Then, the computer executes the body of the loop. In our case, it will simply print that variable. When the computer is done with this operation, called iteration or pass of the loop, Python will go back to the for statement and pick the next element in that is in the even list. It will then print out, and so on and so forth until the loop body has been executed for all available elements in the list. Right, let's apply this code to see the outcome. Exactly as expected. All numbers were stated in a column. What if we wanted to see them ordered in a single line? A comma after the element in the parentheses after the print function, and an in parameter with a value of an empty string will help us achieve that. Note that to specify an empty string, you need to type an empty space between a pair of double quotes by pressing the spacebar on your keyboard once. Thus, the comma and the in parameter will indicate every next element from the loop should be placed with a distance of one space on the same row. And if the elements you're about to print are too long, they will be displayed on multiple rows in the output cell. But you don't need to worry about that at the minute. This was a short but important introduction to the concept of iteration in programming.
See you in the next video, and thanks for watching. The same output we obtained in the previous lesson could be achieved after using a while loop instead of a for loop. However, the structure we will use will be slightly different. Initially, we will set a variable x equal to 0, and we'll say, while this value is smaller than or equal to 20, print x. But please be very careful, and I mean it. If you leave the code until here, you will run into an infinite loop, and your computer will crash. This is a situation you want to avoid, right? So, be very careful. Since x will always be smaller than 20, your loop will be infinite. It will iterate the same variable repeatedly. This is what we did here with x equals 0. And always is not what we want in an iteration. We want to get the loop to end. What is supposed to succeed the loop body in the while block is a line of code that specifies a change in x, or what has to happen to x after it is printed. In our case, we will tell the computer to bind x to a value equal to x plus 2. Let's see if it works. Awesome! This is much better. Actually, there is a term for what we just did. In programming terms, adding the same number on top of an existing variable during a loop is called incrementing. The amount being progressively added is called an increment. In our case, we have an increment of 2. Furthermore, the Python syntax offers a special way to indicate incrementing. X plus equals 2 shows we are incrementing the value of 2 on top of the base x, just as if we had typed x equals x plus 2. As you can see, the two outcomes are the same. To conclude, whether you will use a for or a while loop will depend mainly on your personal preferences. What matters is that your code does not crash and provides correct results. Right? Thanks for watching.
Later in the course, we will need to randomize data points and lists with data points. And that's when we'll be able to use Python's built-in range function. It can help us by creating a Python range object, which actually is a mere sequence of integers.
The syntax of the function is the following. Type range and in parentheses, mark a start, stop, and step value. The start value will be the first number in the list. The stop value will be greater than the last value in the list. It is going to be equal to the last number plus 1. Just classical Pythonic logic, right? The so-called step value represents the distance between each 2 consecutive values on the list. The stop value is a required input, while the start and step values are optional. If not provided, the start value will be automatically replaced with a 0, and the step value would be assumed to be equal to 1. You could also remember the stop value as most important, the start value as less important, and the step value as least important.
For this reason, range of 10 will provide a sequence of 10 elements, starting from 0, implied after not indicating a start value, and ending at the 10th consecutive number, number 9. Python, however, will not display the sequence in the form of a list. Instead, it will show this as a range 0, 10, which stands for a range object with a start value of 0 and a stop value of 10. To display the sequence in a list, we can take advantage of the Python built-in list function, using this very same range function as an argument. In that case, we will obtain a list containing all integers from 0 to 9. The trick that was just introduced to you is something you will need to have under your belt if you are using Python 3 and want to check the values generated by a given range function. Also, remember that Python 2 will handle the situation in a different way. It will directly create and display the sequence as a list, as opposed to a range object. We will show how this can be done later in this lecture. And that's pretty much all you have to know about the range function in Python 2 or 3. That said, let's take a look at 2 other examples. In another cell, if for instance, in the range function, we declare as arguments 3 and 7, Python will accept 3 as a start value and 7 as a stop value of the range. So we obtain a list from this range function. We see that we have 4 elements, 3, 4, 5, and 6. Good. In another example, we may want to specify a step value in a range. To do this, we must choose the first 2 arguments as well. So let's obtain a list with all the odd numbers from 1 to 19 included. I will start with the number 1, and the list will end with number 19, which equals the stop value 20 minus 1. To state the odd numbers only, we must designate a step value of 2. As we execute this cell, we will obtain the corresponding range object. To see the values displayed in a list, we can use the same range function as an argument of the list function. Thus, we'll obtain the desired result, which means that we have worked correctly.
This is how we can create lists with Python's range function. In our next lecture, we'll see how it can be applied in practice. Thanks for watching.
Now that you know what the range function does, let's see it in a for loop. To print all the values from 2 to the power of 0, 2 to the power of 1, and so on until 2 to the power of 9, we can use the following code. For in range of 10, print 2 $n, written in parentheses. I will also have to insert a comma and specify an n parameter with a value of an empty string after n, because I would like to see the output on a single line. Good. I guess you can agree it was not necessary to designate the name of a list that exists in our code. Using a sequence of numbers generated by the range function is going to work too.
Now, let's be brave and create an iteration that includes a conditional in the loop body. We can tell the computer to print all the even values between 0 and 19 and state odd in the places where we have odd numbers. Let's translate this into computational steps. If x leaves a remainder of 0 when divided by 2, which is the same as to say if x is even, then print x on the same line. Else, which means unless x is even, or if x is odd, print odd. Lovely! This is an example of a combination of an iteration and a conditional in Python. There are two main ways to program a loop, and until this moment, we paid attention only to the first one. We have a list x that contains the numbers 0, 1, and 2. We saw we can print out each of its elements by typing for each item in the x list, print out that item. The second way finds its practical application in more sophisticated codes. Its structure takes advantage of the range and len functions in the following way. For each item in a range that goes through the elements from the list x, that is, len with an argument x, print out each item. If we do this, the variable item will loop through a new list created by range, and that has as many elements as the x list itself. Please note that in this situation, the second line of our code needs indexing to extract each item from the x list. In practice, we will print out the element at position 0 from the list x, then the element at position 1, and finally the element at position 2. To conclude, both approaches can lead to the same outcome. Although the second one looks unnecessarily complicated, in advanced coding, it might turn out to be a lot more useful. So, it is important you know both. Don't skip the exercises that come with this lecture, as they will reinforce what you've learned here. Thank you for watching. We use iterations when we have to go through variables that are a part of a list. In this lesson, I'll show you how to count the number of items whose value is less than 20 in a list. First, define a function that takes as an argument numbers, where numbers will be a certain list variable. The trick is to create a variable that, so to speak, departs from 0. Let's call it total. The idea is that when certain conditions are verified, total will change its value. This is why in such a situation, it is appropriate to call this variable a rolling sum. More technically, when we consider x in the numbers list, if it is smaller than 20, we will increment the total by 1. And finally, return the total value. This means that if x is less than 20, total will grow by 1. And if x is greater than or equal to 20, total will not grow. So, for a given list, this count function will return the amount of numbers smaller than 20. Let's verify if this function works properly. In this list, we have 4 numbers that are less than 20, right? Let's check that out. Great! Now, If I add 17, for example, somewhere in the list, the outcome will adjust accordingly. 5. Exactly. Perfect. By the way, look how the whole if statement is indented even more to the right. This allows us to separate it logically from the rest of the code in the cell that refers to this function. If you are eager to know how to iterate over a dictionary in Python, and I am sure you are, you will see this in our next video. Thank you for watching. Let's look at something a bit more challenging, iterating over a dictionary. We have a couple of examples here. The prices of a box of spaghetti, of a portion of lasagna, and of a hamburger are stored in a dictionary called prices. Jan went to the supermarket and bought 6 boxes of spaghetti, 10 pieces of lasagna, and no hamburgers. This data was stored in a dictionary named quantity. Our problem is, how much did Jan spend in the supermarket? Well, it is obvious you'll need to multiply the quantity of each food by its price. You must have noticed our dictionaries have exactly the same keys. We should exploit this. The procedure to go to the box of spaghetti in the first dictionary and take the value of 4, then get the value of 6 from the quantity dictionary, and then multiply those two must be repeated for each food product. That must ring a bell. I am sure you probably think the same. We need a loop. Okay, that's clear. But what are we going to do with it? What is the loop's body going to contain? Before anything else, some variable must account for the amount of money spent, right? Let's implement a well-known trick. I'll create a rolling sum called money spent, which will initially assume the value of 0. So, we can start by iterating over each item in prices, I in prices for short. At every step of the loop, I would like the money spent variable to grow by the product of the price and the quantity of a certain good I. And that should be enough. Let's print the result to check whether we are working correctly. Apparently, yes. Wow! Such a simple problem in terms of mathematics required to connect knowledge on dictionaries, iteration, and creating a variable with an increment. So, from a programmer's perspective, the problem looks different. The good thing is that, at the end, this whole thing boiled down to a mere 4 lines of coding. As a side note, do you realize that if we put quantity instead of prices here, the outcome will remain the same? So, what is the conclusion? It does not matter if you loop through prices or through quantity, because the two dictionaries contain the same keys. And this is the reason this loop works correctly too. It's quite important. This section was a bit more complicated, wasn't it? The exercises you will find after this lesson will be more challenging, so it is quite important you solve them. Thanks for watching. Have you heard of object-oriented programming? It is also known as OOP in brief. In this lesson, we will explain what it is, and this will enable you to handle more advanced programming concepts. In addition, OOP is a stepping stone for explaining modules. We will do that in our next lesson. We can say every value in Python is an object. Integers, floats, strings, lists, they are all objects. Think of them as logical objects. Therefore, object-oriented programming refers to the concept of interacting with one or more objects. Today, there are several languages supporting OOP. Java, PHP, Python, and C++, for instance. The reason programming has evolved to this level is conceptual. Objects allow us to model real-world concepts. For example, we can have a list containing the exact number of visitors in a gallery for March. This is a list containing 31 data points, given that March has 31 days. Or we could enter names of the galleries as string values in a dictionary called galleries. An object contains data, such as a number or a string, plus the operations allowing us to manipulate the data. Okay, excellent. The next thing we'll do is introduce the concepts of classes, attributes, and methods. Each object belongs to some class, defining the rules for creating that object, and we can attach a certain number of attributes to it. Let's use a metaphoric example that will make things much clearer. Uncle Archibald can make bikes, so he belongs to the bike maker's class. He knows the rules for creating a bike. This is a bike he made. Therefore, it is an object of the bike maker's class. As an object, it has certain attributes that refer to the state of that object. Its color, size, and type, mountain bike or road bike, are attributes that can be assigned to it. A method is something different. It is a consequential logic sequence that can be applied to the object. It could be an operation like turn left, turn right, slow down, or accelerate. These actions can be applied to the object, but it is important that, while programming, the focus is on the object and not the action, as it is in other types of programming. This is it. Let's provide a practical example that will help you visualize these concepts even better. We can create a list with 3 floats, and it will be our object. Sometimes, people will refer to objects with the word instance, or they may say properties instead of attributes. This is fine, as these terms can be used interchangeably. The object we created belongs to the Python's list class. One attribute of this list is the type of data in it. Technically, a list can contain various types of data, such as integers and strings. So, it is important to define the type of data used here. These are floats. A method we could apply to this object is extend or index, as we saw earlier in the sequences section. And please pay attention. These operations can be performed only after we have created the object. The difference between a function and a method is subtle and can be confusing. Try to remember, a method is a special function. As any other function, a method can have many parameters of various data types, but it will surely contain the object it is applied to as one of them. A method belongs to a certain class, while a function exists on its own. Looking back at our bike maker's example, if there isn't a bike that's been made, there is no way to apply the turn left method. One of the parameters of the turn left method must be a bike object. To avoid confusion between the terms method and function, the Pythonic syntax is different in the two situations. As we saw in our previous lessons, the method name is not just succeeded by parentheses. It is written after the name of the object it is applied to and the dot operator. Great! This concept will help you on your way to becoming a solid programmer. Let's keep up the good work and continue with the next video where we will explain modules and packages. Thank you for watching. Hi, and welcome back. In this lesson, we will learn about modules and packages. A module is a pre-written code containing definitions of variables, functions, and classes. Its charm lies in the fact it can be loaded in all new programs. And we need not rewrite the code manually at the beginning of a new program. A package is a collection or directory of related Python modules. Technically, you could create your own modules and packages, but things are easier than that. People in the programming community have developed a growing set of packages that are readily available for download and have been tailored for various types of professions and specializations. Sometimes, people use the term library when referring to a package, so please know that the two can be used interchangeably. In our next lesson,
we'll learn how we can work with modules and library tools. Thanks for watching. Python Standard Library is a collection of modules available as soon as you install Python. Do you remember the built-in function len we used earlier in the course? We used it directly, and we didn't have to write down code manually, counting the number of elements in an object, right? Similarly, we used the methods from the list class to extend a list, and we didn't have to define a method on our own before applying it. Well, this was because Python's developers have prepared a certain amount of code run automatically when you start a new notebook file. There is a set of modules there at the beginning of your program. You cannot see it, but it contains all those built-in features like the len function or the list class. Namely, these modules form the standard library. Python has a broad practical application. To use the language, it is not mandatory to install all the modules there are in the world. So, besides the standard library that comes with the normal installation, people download the modules and packages they need. Statisticians will be tempted to install a module comprising a large set of statistical functions and methods, while a data scientist will likely use a 24/7 package that helps him organize his data into tables, and so on and so forth. And to this story, we will make no exception. Soon, we will specify the libraries relevant for our financial lectures. But before we get there, please pay attention to the following. Don't expect to create modules all the time. It is true this is one of the best features of Python, but this is typically carried out by highly specialized experts. For instance, some developers will create a certain statistical module that can be imported and used by anybody. If you are a statistician, you will be happy to take advantage of this statistical module. In most cases, it would be free, and you can download it and use it for your calculations. Once a module has been released, it can still be improved and updated. Frequently, developers team up with statisticians to do that. Modules are a dramatic improvement in Python's efficiency. Once established and proven to be functional, a module can be easily reused multiple times, facilitating the work of thousands of users. In our next lesson, we will focus on the technical side, learning how to import a module in your file. See you there, and again, thanks for watching. There are 4 ways to import a module. In this lesson, we will show you all 4, and then, once you have seen them, you can decide which one you will use when working on your own. Let's learn how to import the math module. It contains multiple mathematical functions. Among them is the sqrt function, which calculates the square root of an argument. By default, this module isn't a part of Python's standard library, but is installed with the whole Anaconda package. So, to use its features, you must import it. Let's see the 4 available options to do that. You can type import math. Now, the code of the math module will be run. To apply the sqrt function properly, we should respect the following syntax. Type the name of the module, math, dot operator, the name of the function of interest, sqrt, and an argument in parentheses. And we obtain the float 4. Wonderful! If you know in advance you wouldn't need all the functions and classes provided in the math module, and sqrt is the only function you'll use, you could type from math import sqrt. The syntax would allow you to omit the name of the module and the dot operator when calling this function. sqrt can be applied to the argument of, say, 25 directly, and you'll obtain the desired result. The third option we'll see is the one experts probably love the most. In advanced bits of code, you will see how modules or their functions can be renamed simply because using shorter names can be time-saving. If we write from math import sqrt as s we can use S instead of sqrt. Applied to 36, this function will return the value of 6. Great! Modules can be renamed too. Let's redo the first option. Type import math again and add as m. Accordingly, m.sqrt of 49 will result in 7.0. You see? The fourth option is usually frowned upon by specialists, but can be appropriate for interactive sessions. Type from math import star, and all the features from math, functions, classes, or methods will be imported. Interpret it as import everything from math. To verify we did things right, let's apply sqrt to 64. Here's our result. Excellent! The problem is this option could be problematic for Python in some situations. Suppose you imported everything from math, and then you imported a second module that contains an sqrt function. And what if the second module uses the function differently? Which of the two should the software apply when you type sqrt of 81? Python will choose one of the two functions, but you won't be able to select the one that should be applied. This is a sign of unprofessional coding, so it is avoided by experts in longer files. In addition, for further reference, you can read about the features related to the math module. Type help and put math in parentheses. A description of all the functions will follow. If you are interested in the meaning of sqrt, then you could simply type help, open parentheses, math.sqrt, close parentheses. Nice! This will do for now. In our next lesson, we will discuss which libraries we'll need for the rest of the course. Thanks for watching. All right, excellent. Let's look at the libraries we will use in this course. Everyone who uses Python for scientific computing uses NumPy, a third-party package allowing us to work with multidimensional arrays. We will talk more about arrays in our next lecture, but for now, think of them as tables of elements. They represent a powerful way to organize and process data. Because of that, NumPy is a fundamental library for those who attempt to manipulate larger chunks of information. Pandas is a package that enhances NumPy even further. It allows us to organize data in a tabular form and to attach descriptive labels to the rows and the columns of the table, not just numbers as it is with NumPy. In addition, Pandas is endowed with a broad gamma of tools facilitating our work with various data formats and missing data. It is suitable for working with time series and huge databases. Therefore, if you want to do data science with Python, Pandas is an essential package you will need. While we introduce the financial topics of this course, we will use Pandas in all Python lectures. Once you do the congruous exercises, you will see why it is regarded as the main data analysis tool in Python. And if you wonder about the name of the package, it is derived from the econometric term panel data, referring to multidimensional data sets. When your calculations are ready, it is vital to know how to present the results obtained in a graph. Matplotlib is a two-dimensional plotting library specially designed for visualization of NumPy computations. In addition, it contains a large set of tools that can help you adjust a graph to your liking. NumPy, Pandas, and Matplotlib are part of the larger SciPy group of libraries. We will not delve into its peculiarities, but to put it briefly, SciPy is a Python ecosystem containing a lot of tools for scientific calculations, suitable for the fields of mathematics, machine learning, artificial intelligence, engineering, and more. Regarding modules, you already saw the Math module. Its name unambiguously tells you it contains mathematical functions. We will also use random, which invokes random number generators. A prominent module for statistical analysis, tests, and models is Stats Models, containing an extensive list of descriptive statistics, plotting functions, regressions, and more. These are the three main modules we will need throughout the rest of this course. Did you notice I imported all these libraries and modules directly? So, they must be contained in the standard library. Well, they aren't. However, when we installed Anaconda, they were included in the package. This is why you don't have to install them separately, as you might have to do if you use some other software for programming in Python. And here is how you can install a package you don't have on your computer. Pandas, as a library, provides access to a large set of classes and functions, but extensions can be added. During the course, we will use the Pandas Data Reader package. The quickest way to install it is by opening your Start menu and searching for the Anaconda prompt. Type pip install Pandas Data Reader in the following way. Pip per se means either pip install packages or pip installs Python. Strange, but true. Anyway, press Enter. When the operation is done, check how you can readily import the module. This is one of the quickest and easiest ways to install modules and packages on your computer. Great! We are speeding up. Now that we've covered the preliminary preparations, we can focus on using Python to carry out financial and data manipulation tasks. In our next lesson, we'll learn about arrays. Thanks for watching. Arrays are fundamental data structures in any programming language. At first sight, arrays are similar to lists. They represent objects, and the objects in an array are called array elements. The main difference between an array and a list is that all the array elements must be the same data type. For instance, they should all be integers or floats. The situation with lists is different. A list may contain an integer, a string, another string, and so on. Okay, perfect. Now that we know what an array is, let's create one and explain its main features. The first thing we will do is import NumPy, as this is the library for scientific computing. You will often encounter the convention NP, which is simply an abbreviation. Let's use it here. Good. Now, I will assign a NumPy array to the variable a. Within parentheses, I will place a list of lists. The first one will be composed of the values 0, 1, 2, and 3. And the other list will contain 4, 5, 6, and 7. Let's look at A now. Apparently, A is an array in which the two lists are shown one above the other. Great! Pay attention to the fact that the NumPy n-dimensional array type is referred to as an ND-ray, and it is always homogeneous. This means all blocks should be of the same data type and interpreted in the same way. For instance, if I put John in the place of 1 in the first block, an indication there is something wrong with the data type will pop up. The same will happen if I delete the block. See? So, your job will be to organize your arrays with the same number of elements and to ensure these elements are of the same data type. Let's restore the previous selection of values. Okay, good. To help you internalize the syntax we just used, consider that array is a function. The structure is identical to the one for methods from a certain class. But here, NumPy is not just a class, it is something bigger. A whole package of several modules, and each containing classes on their own. np.array is the way to apply the array function. It takes a few lists as arguments and returns a data structure in the NumPy array format. Fantastic! To see the shape of the array, just type a.shape and you will obtain a tuple indicating the object has 2 rows and 4 columns. Ignore the L characters after the digits. They simply refer to the data type of the obtained values, which is long. Nice! And how can we access one of the values in an array? I'm sure you know the answer. In brackets, type the number of the row and then the number of the column. Count from 0 in both cases. So, A brackets 1 and 3 will return 7. Exactly. Perfect. You know how to change a value in an array. Designate the position of the value you would like to substitute, say 1 and 2, corresponding to the value of 6, and, after the equal sign, type the new value, say 8. Perfect. The second row of our array becomes 4, 5, 8, and 7. Last, what do you think will be the result if you pass a single value within the brackets? What will A0 do? This will extract the 0 row for you. And A1? Index 1 row. Wonderful! Okay, probably you are wondering why arrays are so important and how they can help us when analyzing financial data. Well, array is the data structure that will carry and organize values into vectors, matrices, and other multidimensional objects. Let's make a quick reference to mathematics. A vector is an object that has both a magnitude and direction, right? So, on a Cartesian plane, the vector b of 3 and 5 will be this line. In Python, this vector can be written as a NumPy array of a single list with elements 3 and 5. A one-dimensional array is also called a vector. Following the same logic, a two-dimensional array is called a matrix. Matrices are the linear algebra term that financiers use in almost every calculation, and they cannot live without them. Mathematically speaking, a matrix is a two-dimensional representation of data to which many powerful mathematical operations can be applied. I am talking about summation, subtraction, multiplication, transposing, and so on. These features let you manipulate data, and the NumPy array is the Pythonic tool that allows you to do that. Lovely! If the concept of arrays seems slightly vague, don't worry. As in the next lessons, we will go through it often. Actually, by the end of the course, working with matrices will seem like a piece of cake to you. When working with financial data, you won't always base your calculations on existing data. Sometimes it will be necessary to run simulations and examine hypothetical scenarios, because observed data will be insufficient. In these situations, you will need a whole set of randomly generated numbers. Not surprisingly, Python can cope with this challenge. First, we will have to import the random module. The random function will generate a random float in the range from 0 to 1, 0 included, 1 excluded. The obtained number would represent the probability of an event happening. The probability must be between 0 and 1, right? Let's print the probability we obtained. As you can see, this is a value between 0 and 1. Another random generator is the randant function, which, as its name suggests, will randomize over a provided interval and will deliver an integer value. Let's, so to speak, throw a die in Jupiter. We'd like to see an integer from 1 to 6, right? I'll execute the command. And here is the result. This is my lucky number, actually. I hope you'll agree, it is even more exciting that we can generate more than a single number. How can we fill in an array with values? The word array is reminiscent of the NumPy library, right? Let's import it. Good. The code we'll use is the same. Just attach it to the NumPy library and provide a third parameter to the random function. The latter will indicate the number of rows and columns in the newly created matrix. I'll improvise with a 4 by 6 matrix. Bingo! We were able to fill in the matrix. It is important here to show you Python's mechanics allows for generating numbers in various data structures, and this feature will be relevant later when we learn how to perform Monte Carlo simulation, one of the most popular tools in the world of finance. Keen on learning how you can import real-life data in Python? Well then, that's what we'll learn how to do in our next video, so please stay tuned.
Before we proceed with the course, let's perform a quick analysis of what it is like to work with financial data. To begin, there are many online sources that provide such information. They can be split into two categories, paid and free. Logically, data from paid online financial data sources is well structured and rarely contains missing values. Alternatively, free data sources do not necessarily contain wrong information. They can provide good enough data quality to help you manage your personal finances, among other things. It is just sometimes not as precise or as rich compared to the data provided by paid websites. That's why we have based our course data on free online sources. It suits the goal of our course perfectly and comes at no cost for the user. So, let's recap. What is Python for Finance, Investment Fundamentals, and Data Analytics about? Up to this point, this course has been focusing on teaching you programming skills in Python. For the rest of the course, additionally, we will look at the fundamentals of finance and investment. We will go through various analytics topics, and we will show you how they can be applied to real-life data using Python. So, it's important to emphasize that these three tools are the main focus of this course. They are the ones that will give you the edge in the market. Another crucial ingredient for making good analyses is the data you'll be using. So, you can be certain that dealing with high-quality information will have a significant positive impact on the outcome of your work. However, the amount of data available is constantly changing, and there's no way you will make exactly the same conclusions if you were to do the same analysis today versus a year from now. Moreover, provided that in this course you use data retrieved from free online sources, it is understandable that you will sometimes encounter slightly erroneous numbers or stumble upon missing values. Nevertheless, we do insist that the important skills and tools that you will acquire are universal in programming, coding in Python, thinking analytically, and solving finance exercises using Python. Thus, data comes as a secondary ingredient. Having said that, let's move on to the next video, where we will shed some light on the current online financial data sources you can use when taking the course. See you there! Please feel free to refer back to this video as you proceed with the rest of the lectures. We realize that some of the topics we mention here might seem a bit too technical for this stage of the course, but at the same time, we believe now is the right moment to share this information with you. So, please do not skip this lecture. Let's look at using financial data from a technical perspective. First, the data you'll be using for financial or any other type of analysis comes from one of two sources: a web server or your computer. In practice, to access data stored on a web server, you'll need to connect to its API, Application Programming Interface. In our case, we will need financial data APIs. We can call them online financial data sources as well. Examples are the IEX, Morningstar, AlphaVantage, and the Quandl APIs, amongst many others. As a quick note, we must mention that a characteristic of these servers is that they provide up-to-date data. That's why you'll need an internet connection to access these APIs. And furthermore, from the point of view of Python, the Pandas data reader is an example of a module that will help you retrieve data from the financial data sources and prepare them for analysis. Apart from extracting online data, you may use information stored as certain types of files on your computer. A file format that every programmer or analyst must know how to work with is the comma-separated value format, frequently abbreviated CSV. Logically, you won't need an internet connection to use data stored in CSV. However, it will typically not contain up-to-date information. It is important to know that neither of the two approaches are straightforward. However, in the next few videos, we will clarify how each of them works and introduce you to the relevant programming tools. This will be a valuable addition to your skill set. As experts often say, it is usually much harder to clean and organize your data well than to conduct the subsequent business or financial analysis. At first glance, it seems from this lecture that you should lean toward APIs, doesn't it? They provide the newest data, and all you need is an internet connection. So, why bother using CSV files at all? Here's why. First, web services are prone to breaking down for unknown periods of time. Second, it is possible that a certain API may contain only part of the data you need for a proper financial analysis.
Currently, some APIs offer just single or multiple stock data, while others may provide foreign stock data or market indices data. Note that an analyst may often need to work with all of these. Furthermore, you can only connect to some APIs if you use Python 3, and not when using Python 2. Meanwhile, others are okay if you are using either of the two versions. Actually, there is a free API, the Yahoo Finance API, which provides all of the above-mentioned types of data, and it does that for any version of Python. Being perfect for the objectives, it is the API on which we have based our entire course. That's why, as you proceed, you will see we have used Yahoo as a data source in our code. However, online data from Yahoo may not always be available. Once, on a very gloomy day, Yahoo's web services were interrupted. So people who do financial analysis had to look for a substitute. The Google Finance API was around, and it could substitute the functionality provided by Yahoo to a great extent. However, its services were discontinued too. Why internet behemoths like Google and Yahoo may discontinue such services is beyond us. But hey, it is what it is, and we have to adapt.
So, focusing on our course rather than the constant appearance of new APIs, the statement we want to make here is the following. To be sure that the entire financial part of the course flows smoothly from A to Z, use the CSV files attached to the videos. Although the information contained there is not up to date, it will be most appropriate as it is the richest and easiest to handle data we can provide. It will allow you to focus on coding, financial theory, and the relation between the two. As we already mentioned, these are the most important skills you acquire in this course anyway.
And if you wonder how the CSV files were created, we must say they are based on data retrieved from the Yahoo Finance API at a moment in which it was functioning. However, if this sounds complicated, just remember the CSV files can be found in the resources section of each financial lecture. They are the ones that fit the course goals best. Now, if you insist on working with up-to-date financial data that is free and the Yahoo API is not available, we suggest you use the Morningstar or the AlphaVantage API, regardless if you are using Python 2 or Python 3. Only use IEX if you are on Python 3.
However, please remember, we cannot guarantee you will always have access to such services. They can be interrupted, which means downloading data from them may become temporarily or permanently impossible. We will post messages in the announcement section of the course if there are major changes in the status quo that must be shared with you. Nevertheless, if you are not able to pull the exact information needed for a specific financial lecture, be prepared to have to change the API or to swiftly switch to CSV files. We know this is a long and slightly confusing lecture, but we had no choice. We had to prepare a video introducing you to the options we have when using financial data in Python. In the next video, we will show you how we distributed the relevant notebook files in the course, and we'll show you how to access them. See you there! Here's how we have organized the two types of data. In the resources section of each video where we work with financial data, you can find folders with the names CSV or Online Financial Data, APIs. In each of these folders, we have separated the notebook files into two groups, Python 2 and Python 3. Thus, you can access the code that will run on your Python kernel directly. If you see one file contained in the Python 3 folder and not in the Python 2 one, this means that the API or type of data will only work with Python 3. We have done this so users have more options when working with either version of Python. We would like to emphasize that you can complete the course using any version of the programming language. So, for instance, as you click on the resources section of the lecture about calculating a security's rate of return, you'll see two Dropbox folders. If you click on CSV and then on Python 2, you will see the notebooks you can download and use in the Jupyter dashboard. If you go back and choose Online Financial Data, APIs, and then select Python 3, you will have notebooks in front of you that will be relevant if you are using Python 3. Finally, the names of all notebook files end with _CSV, _morn for Morningstar, _IEX, and so on, to help you distinguish the files related to the different sources. CSV files should be your first choice. Their data is the richest and has been extracted from the Yahoo Finance API, on which this course was initially based. This means that you will not face problems with missing values when working with single or multiple stocks, foreign stocks, and market indices. If you want to try working with the APIs, you can access the respective folder and check the files provided in there. All right, I hope you appreciate this video, even though it might have sounded a bit too technical. Now, let's get back to business. In the next lecture, we will resume coding in Python and see how to import real-life data from an online data source. Catch you later.
All right, excellent. In this lesson, we'll continue to explore fundamental techniques that will help us improve the organization of data in Python. Logically, the focus will be in the pandas package, and NumPy will help us illustrate the subject better. One of the two main data types defined in pandas is series. You can think of it as a single column data, a set of observations related to a single variable. Let's create the variable SER that will carry the information. It will be of the series type, and I would like it to contain 5 random numbers. Hence, I can use NumPy's random function to create the 5 random numbers. All right. What is left is to assign a number to the column. Column 1 sounds okay, doesn't it? Great. The indices on the left side of the screen show rows index, counting from 0, and the 5 randomly generated numbers, just as we expected. You can think of a series object as a dictionary, whose items are of the same data type. Here, we had float numbers, right? Therefore, you could access one of the elements through its index, just as you would do with a dictionary. SER2 in brackets will return the third value from our column. Great! The other data type is called data frame. It is like the series data type but with several columns. Before dealing with data frame, we should get acquainted with the following. Let's import data from the Pandas data reader package we pip installed, not to get confused with the datasets we will later create in our notebook files. Let's rename this item with the following convention, WB standing for Web. Okay? Our goal is to extract data from Yahoo Finance about Procter & Gamble starting from the 1st of January 1995. The function dataReader will allow us to do this in one row. Let's call the dataset PG, as in Procter & Gamble, equals, then from the web package, use this dataReader function. And as parameters, you should specify 3 important items. The first one is Procter & Gamble's ticker. A ticker is the symbol with which a company's shares are quoted on the stock exchange. For example, Procter & Gamble's ticker symbol is PG, Apple's is AAPL, and Microsoft is MSFT. Good. So after PG, we should determine a data source. It will be Yahoo. Perfect. Finally, let's specify which data we want extracted. The start date will be the 1st of January 1995, written as 1995, 1 and 1 all hyphenated. We shouldn't forget to place the last 2 items within quotes. Excellent! This is how we can extract real-life historical data. Exciting, right? In our next lecture, you will learn additional tools that will be helpful for data analytics. Thanks for watching. In our previous lesson, we extracted P&G's historical price data since 1995. Let's look at it. Wow, a lot of data. Python does not even project the whole range. Here's a piece of advice for you. Once loaded, look at your data first. A short preliminary analysis doesn't hurt, but can be helpful and might prevent losing valuable time. If there is something wrong with the data, it is better to find it sooner than later. Let's see how Pandas organizes a data frame. The first 2 rows are not counted as rows with data. Open, high, low, close, volume, and adjusted close are just the column names, while the information in this cell refers to the labels of the rows. The data we extracted is a time series. In every trading day, P&G's price has been recorded, and here we can see it. This is why in this cell, we specify the labels below refer to a date. Therefore, the 0 row with data is this one. The first one is this one, and so on. Okay, the data looks good. We have 6 columns containing 4 types of price information, trading volume information, and finally, the adjusted closing price of the stock. The adjusted closing price for the first years seems a small number compared to the closing price we see here. But at the end of the period, we can see it is equal to the closing price. The difference is due to dividends paid to stock owners and to other changes to the stock price, such as stock splits, increases of capital, and so on. So, at this point, the data looks fine, right? Let's look at the date values we have here. When we extracted everything, the data from the 1st of January 1995, do you think we obtained information about every day or just about trading days? The latter means Saturdays, Sundays, and national holidays will not be quoted, as the stock market isn't open in those days. It looks like we are in the second case, no data for the 1st and 2nd of January, which sounds normal. Nothing about the 8th and 9th of January. Okay. The data we have here includes trading days only. Therefore, we can conclude the data is clean and well organized, and there are no missing bits. Hence, we can proceed with further analysis. A few Pandas methods can speed up this analysis for you. .info will first tell you we are examining a data frame object. You can see how many entries there are and the time span. Here, you can easily see the number of data points. As each row is the same, this immediately tells you there is no missing data, which is great. Finally, besides the volume column, containing integer values, the data in the rest of the columns is made of floats. Okay. Head and tail are the two methods you can use when you would like to see the first and the last 5 rows of your data. If you are interested in a different number of rows from the top or the bottom, you must indicate the specific number within the parentheses. Let's see the first and the last 20 rows of our data set. Done. Wonderful. We are one step away from completing the data organization concept. We learned how we can extract from Yahoo a data frame object with 6 columns, right? So, the next logical question would be, how can we create a dataset that contains 5 columns representing the adjusted closing prices of 5 different companies? We want to repeat the same action we just did for Procter & Gamble for, say, Microsoft, AT&T, Ford, and General Electric. But I will need only the last columns of their tables. The task at hand is clear. Here is how we can do it. First, we will have to create a list with the ticker symbols of the companies I just mentioned. They are PG, MSFT, T, F, and GE. Do you remember how we create a dictionary by typing its name and assigning it to an empty value within braces and then filling it with key value pairs? The logic of what we will do here is similar. I will create a new data frame object from Pandas and will call it New Data. How will I fill it with information? Row by row for the past 22 years? No, I'd rather remember what I know about iteration in Python. And I'll write for every ticker in tickers, T in tickers for brief, provide me with the adjusted closing price for each ticker for each instance. That is, for each day since the 1st of January, 1995. The correct syntax is: to new data with an index of T, assign the outcome of the data reader function for T from Yahoo, starting from the 1st of January, 1995. This line is analogical to the one we used for downloading the data of P&G. The difference is that, here, we had the index T in the new data object at the beginning. And, importantly, since we are interested solely in the adjusted price column, at the end of the line, we should indicate in brackets the exact name of the column. Okay? Good. This trick will work only if the data for all 5 companies is organized in the same way, with the same column names. And is it so? Let's execute and check the tail of the new dataset. Looks good, right? We are almost there. In a few lessons, we'll carry out financial and investment analysis in Python. Thanks for watching. First, to retrieve information about a single stock from IEX, it will suffice to substitute Morningstar with IEX and 1995 with 2015 in this line of code. Then, you can execute the respective code cell. See? We obtained an analogical output with stock prices starting from the 1st of January 2015 because IEX does not provide data for more than 5 years prior to the date in which you execute the code. Now, let's explore how one can extract a multiple stock list from IEX. To begin, we will have to create a list with the ticker symbols of the companies I just mentioned. They are PG, MSFT, T, F, and GE. Do you remember how we create a dictionary by typing its name and assigning it to an empty value within braces, and then filling it with key value pairs? The logic of what we will do here is similar. I will create a new data frame object from pandas and will call it new data. How will I fill it in with information? Row by row for the past 22 years? No. As already mentioned, one of the problems related to working with IEX is that only data for the past 5 years is available. However, while this API provides a limited amount of data, it is perfectly suitable for this course. Therefore, we can still use it for this exercise. Now, instead of filling the data frame object with information row by row, I'd rather remember what I know about iteration in Python. And I'll write for every ticker in tickers, T in tickers for brief, colon, provide me with the closing price for each ticker for each instance. That is, for each day since the 1st of January 2015. The correct syntax is to new data with an index of T. Assign the outcome of the data reader function for T from IEX, starting from the 1st of January 2015. This line is analogical to the one we used for downloading the data of PNG. The difference is that here, we had to index T in the new data object at the beginning. And, importantly, since we are interested solely in the closing price column at the end of the line, we should indicate in brackets the exact column name. Remember that this API uses only small letters for writing its column names, so we must type close in lowercase letters only. Okay. Good. This trick will only work if the information for all 5 companies is organized in the same way, with the same column names. And is it so? Let's execute and check the tail of the new dataset. Looks good, right? So, as you can see, online data sources only provide a limited part of the information we need for our analysis. In addition, in the notebook files attached to these videos, we will also explain how you could use another API, Alpha Vantage. However, this one is not the easiest option from a programmatic point of view. The benefit, though, is that it contains a large amount of data, which is rather rich. Therefore, if you are interested in feeling prepared enough about coding with Python, or you are up for a challenge, please do check these notebook files. Alternatively, stick to the CSV files that we will show you how to use in the next few videos. In the meantime, don't forget that by pressing the link provided in the resources section of the videos, you can access files that contain the code shown in the videos. We encourage you to check out the notebook files thoroughly, as oftentimes they contain additional and useful information. Thanks for watching. Loading data in Python is not always as straightforward as one would presume. Simply, there isn't a single file format in which data can be stored. In this lesson, we will go through an overview of the most common data file formats and show you how to load and save data in them. You saw how you can extract data from the web with the help of the Pandas Data Reader module. Let's see how we can import data with Quandl. Quandl is constantly growing and receiving critical approval. You must be able to use data from such sources. We pip installed the Quandl module in one of our previous exercises, remember? So, if we create an object called MyData01 and assign it to the Fred GDP data from Quandl and apply the get method, our data will be readily available. Is that the case? Let's look. I'll apply the tail method, and here's what we could obtain: the last 5 entries visualized. And how about the first 10 entries? Wow, this data is available for a period beginning in 1947. Amazing! The comma-separated value format, also known as CSV, is popular today. We can save the Quandl data we have here into a CSV file. After we import the pandas library, we must apply the to_CSV method to my data01 and in parentheses, within quotes, indicate the directory where we would like to store the file. We must end the expression by indicating a file name and the .csv file format. Let's verify this approach by checking what we have in that folder. The example 01 CSV file is there. Lovely. Logically, we could also open a comma-separated file. The method to use here is read_CSV. We must comply with the same rules about specifying the directory of the file. Our object is called MyData02. Let's check its first and last rows. Great, it all works. When we want to save or load an Excel file, we have to follow the exact same steps. These are both pandas methods. To save the last data frame object in an Excel table, we must apply the to_Excel method. Let's call the worksheet file example02 and apply the XLSX format at the end. And when we open the designated directory, we will be able to see everything's okay. And to open an Excel worksheet, let's create MyData03 and apply the pandas read_Excel method. Don't forget to indicate the correct XLSX file format here. Wonderful! We obtain this 52-row Excel worksheet data. Congratulations! You just concluded a set of Python lectures that introduced you to more advanced topics that allow you to manipulate data easily. Our next lecture is very important. It will take you through the process of working in a multidiscipline environment, combining knowledge from the quantitative and the programming worlds. Straight after that, we will dive into financial and investment-related topics. Thank you for watching. In finance, you will constantly work with time series data, representing a series of data points indexed chronologically. Therefore, when working with such data, you can plot the values of economic variables in time. For instance, such was the data you imported in the previous video from the data02 CSV file. However, we see the date values have been included in another column, while the entire dataset has been plotted against the numbers from 0 to 1204. Why? Well, Python automatically assigns numbers to every row of your data, starting from 0. In Pythonic terms, we can say Pandas has rendered the data default integer index. Hence, in this and in similar situations, our job will be to set another column as an index of the table. There are 2 ways to do this. Let's look at the MyData02 table. We must plot the data against the values in the date column. Hence, we can upload the data once more. But this time, we will add a comma and index column, written index COL, equal to the name of the column of interest, date.
Let's run this and the next cell to see if we have obtained the desired output. Absolutely. Date is our new index. Okay, let's scroll down and observe what we have in MyData03. A column named Year and some economic indicators. You can use the Year column as our index. This time, you could have the data loaded, but then you must use the set_index method to solve your task. And in the parentheses, you must indicate the column of interest, year. Let's execute this cell to see if we have worked correctly. 100%. Perfect. There is one tricky part regarding the second approach we used. Set_index will just display the data with the index you have indicated. If you retrieve the content of the MyData03 table, you will see it will still be with an integer index. The trick that will solve this problem is to use the set_index method to reassign the content of the variable MyData03. When you check its content, you will see it is of the new format, having year as an index. Is that so? Yes, it is. Amazing! These are the two ways to convert a table with information into a time series data in Python. Thank you for watching. This is a video in which we will share two specific Jupyter functionalities with you. If you have worked on a file and have closed it after having run its code cells, the next time you open it, you will not see the code in the input cells only. You will see also the obtained results stored in the output fields. Now, imagine you would like to run the cells from the very beginning. What should you do? The best way to do that is to expand the kernel option from the Jupyter menu and select the option Restart and Clear Output. After you click on it, you must confirm by pressing the Restart and Clear All Outputs button. Then, we will see the only thing left in the notebook file is the code. None of these cells have been executed. That's why there is no number associated with the input cells. So, after we execute the first cell, it will have the number 1. The next one will be numbered as 2, and so on. Great! The other interesting option would be to select Restart and Run All after expanding the kernel option from the Jupyter menu. It will basically proceed similarly to the option we just saw. This time, however, Python will run all code cells from the first to the last, unless it encounters an error somewhere on the way. In case some cells contain an error, Python will simply stop there. In our case, there were no mistakes in the code, and the cells were set in the correct order, so everything will run from the beginning until the end. Is that correct? Yes, lovely. These options can be applied anytime you must redo what you have done with the notebook file. This usually happens after spending a long time on a document when you want to verify your code can run smoothly from the beginning to its end. We hope you enjoyed this video. Thank you for watching.
When we think of an investment, we have to remember two things: its upside and its downside. In other words, we should consider the profit that will be made if everything goes well, and the risk of losses if the investment is unsuccessful. This is valid for every venture. Whether you are buying the shares of a company, corporate or government debt, real estate properties, gold, investing in mutual or a pension fund, you must consider these parameters: the profit you can expect and the risk of losing money. But why do different investments have a different level of risk and profitability? A comparison between bonds and stock can highlight the difference. Government bonds offer an average rate of return of 3%, and historically there have been very few cases of governments going bankrupt and not repaying what's owed to investors. So, some risk comes with this investment. It isn't risk-free, but the risk is very contained. If an investor buys government debt, he can be certain that 1 year from now he will obtain his initial investment plus the expected interest. Equity shares have a higher rate of return, approximately 6%. However, they are associated with much more frequent fluctuations and price changes, as different variables influence a company's share price. Operations, competition, regulatory environment, strategic decisions, industry trends, a lot of things can go well, but there's a lot that can go wrong. An investor who buys equity shares should know the higher return he expects comes at the price of high uncertainty and risk. Makes sense, doesn't it? Therefore, we can conclude that the art of finance isn't about maximizing an investor's returns in a year, it's about making informed decisions that consider both dimensions, risk and return, and optimizing the risk-return combination of an investment portfolio. Get excited, as this is exactly what we will learn how to do in these lessons. Now that we understand the importance of risk and return of financial securities, such as stocks and bonds, we are ready to learn how to calculate the two parameters. In this part of the course, we will use a very structured approach. Concepts will be explained in theory first, so you understand their meaning and purpose, and then we'll teach you how to perform the actual calculations in practice using Python. We are going for the trifecta: theory, real-world application, and use of Python. Awesome! So, in the first few lessons, we will focus on rates of return. We will start by learning how to calculate the rate of return of a single security. Then, we'll continue by calculating the rate of return of a portfolio of securities, and we'll explain stock indices and how they are composed. In the next part, we'll learn about risk and the statistical measure that allows us to measure risk, standard deviation, and variance. Next, we'll examine the relationship between two securities, also known as correlation, and we will teach you how to calculate the correlation and covariance of two securities. These are some of the fundamental concepts you need to understand before calculating a portfolio's risk and learning about the benefits of diversification. The course continues with a very interesting topic: regressions. You will learn what a regression is, how to run a regression, the alpha and beta coefficients, and how important a regression's R-square is. Once we've covered these topics, we will be ready to introduce Markowitz's efficient portfolio theory, one of the cornerstones of modern-day finance theory. One of the most interesting extensions of Markowitz's work is the capital asset pricing model, which is the most widely used model in the world of corporate finance today. We will learn how to calculate a company's cost of capital, its beta coefficient, and its Sharpe ratio. Monte Carlo simulations is another venerable topic we will explore in this course. We will apply them in the context of derivatives and options pricing, and in a corporate finance budgeting exercise. Sounds great, right? I know, you can't wait. Let's get started then. Every investor's main goal is to earn a good rate of return on his investment. What do I mean by that? Well, imagine you've bought one share of Apple's equity at the beginning of the year. Back then, Apple shares were trading at $105. At the end of the year, their price increased to $116. So apart from any transaction costs arising from the transaction and dividends paid by the company throughout the year, if you sell your one share today, you will receive $116. So you've made a profit of $11. Is that a lot? Should you be happy with the investment you've made? The only way to answer these questions is by comparing the investment in Apple shares with other investments, the amount you would have earned if you had bought other stocks. However, different stocks have different prices, right? Therefore, we need a measure that ensures comparability between investments with different market prices. And that's easily done. All we have to do is calculate a percentage rate of return of the investment. Once we do that, we can compare it to other investments. The rate of return of the investment is given by the ending price minus the beginning price, and that is divided by the beginning price. So, in our case, it will be given by $116 minus $105 divided by $105. This gives us a 10.5% rate of return. This computation of the rate of return is called simple rate of return. It's clear how we calculate a simple rate of return of an investment, right? The amount we've made minus the amount we've invested divided by the amount we've invested. If we assume Apple paid a $2 dividend at the end of the year, the rate of return calculation becomes $116 plus $2 minus $105 divided by $105. The simple rate of return becomes 12.4%. Okay, great. We can calculate the logarithmic return of the investment by calculating the logarithm of $116 divided by $105, which is equal to log of $116 minus log of $105. The result we obtain by using the log formula is 10%. Simple and log returns provide a slightly different result, so it is important to be consistent with the way we calculate returns. If we've chosen to calculate simple returns, we have to do it for all further financial calculations. And if we decide to calculate log returns, we should use only log returns. Which one should you choose? Well, there isn't a general rule. However, most econometricians believe simple returns are preferable when you have to deal with multiple assets over the same time frame, and log returns are preferable when you make calculations about a single asset over time. There's an important observation we have to make here. We should always remember the time frame for which we've calculated a rate of return. In the example we saw here, we calculated a yearly rate of return because the Apple stock was held from 1st of January to the 31st of December, one whole year. We can use the formula to calculate rates of return for periods different than a year, but we should be careful as investments with different holding periods shouldn't be compared. We should always remember the time frame of the rates of return we are working with. Typically, investors use daily, monthly, quarterly, or yearly returns. The most popular expression is annually. In addition, we can easily convert daily, monthly, and quarterly returns yearly. We only have to use the following formula. By applying it, we can easily adjust for daily, monthly, and quarterly returns. All right, now that we know how to calculate an investment's rate of return, and how to convert rates of return with a different holding period in annual rates of return, we are almost ready. We only have to explain the connection between historical and expected rates of return. Everybody in finance is interested in future rates of return. Given that, until now, scientists and researchers have not found a way to predict the future, we need to figure out a way to form an idea about future rates of return. We can't predict them, but we can form a reasonable proxy and call that proxy expected rate of return. The best idea we can have about a financial security's expected rate of return is its past behavior. We've observed the security's historical performance, and that information can help us build expectations about the future. In our next lesson, we'll calculate a security's historical rate of return in practice. See you there.
All right, excellent. Now that we have covered some theory, we are ready to apply it in practice and calculate a security's rate of return using Python. In the first cell that you see here, we will import NumPy and the Remote Data Access module from the Pandas Data Reader package. The third line of code is new to you. We import matplotlib/pyplot, which is a collection of distinct style functions from matplotlib that will allow us to work with charts and edit their elements easily. I will rename it PLT. The next few lines of code you can see here should be familiar. We are simply importing Procter & Gamble data from Yahoo Finance for the period from the 1st of January 1995 until today. To confirm we did this operation correctly, we will check the first and last 5 data observations. All right, everything seems to be fine. It is very good practice to go on the internet and check the data you are using is the one you need. We download our data from Yahoo Finance, so we can expect to see the same values on their website. Let's go to Yahoo Finance. Search for PG, which is Procter & Gamble's ticker, and then click on Historical Data. If you check the prices date by date with your document in Jupyter, you will see they are aligned with P&G's stock price, as seen on Yahoo Finance. Perfect! We can use this data for our analysis. We have everything that is necessary to calculate P&G's rate of return from 1995 until today. As we said in the previous lecture, a simple rate of return can be calculated as the difference between the stock's price on day 1 minus its price on day 0, divided by the price on day 0. And when we say price, we mean adjusted closing price. The adjustment that has been made reflects dividend payments to shareholders and operations such as stock splits. For the analyses that follow, we will use the adjusted closing price as a reference for our calculations, which is the rightmost column in this table. An alternative way to write the formula for simple returns calculation is today's prices divided by yesterday's price minus 1. This is going to be a bit more helpful in this example. We will first divide the price on day 1 by the price on day 0, and then we will subtract 1. Okay, good. We've managed to extract more than 5,000 daily observations of P&G's stock price. For each of them, we want to calculate a simple daily return. The first daily return in this series will be equal to the adjusted stock price on the 4th of January 1995, divided by the adjusted stock price on the 3rd of January 1995, minus 1, and so on. The best way to organize this data is to do it in a column. Here's how we can create one. I'll start with the name we use to label our data, which is PG, and then within brackets, I'll type the name of the new column we would like to create. Simple return sounds logical, right? Okay. Now, within parentheses, I indicate the adjusted close in a given day, and then divide it by the adjusted close in the previous day. How am I doing that? As you can see, the shift function helps me do that. The argument of the function determines the number of lags I am interested in. Here, I will need the value from the previous trading day. Therefore, we should indicate 1. The whole series in the denominator shifts, and we can easily divide today's stock price by yesterday's stock price. To complete the formula, we have to close the parentheses and subtract 1. Let's print the variable and see if it worked correctly. Absolutely. We obtain a series of data, and it looks like what we expected in the first place. It exhibits the percentage daily change of the adjusted closing price. On most days, the number is lower than 1%. Significant movements of a company's stock price are not an everyday occurrence. Please pay attention to the first value of the series, NAN. It stands for not a number, and it makes sense since there is no lag for our first observation recorded in the trading day on the 3rd of January, 1995. Stay tuned for the next lecture, where we will use these numbers to obtain meaningful statistics and graphs. Thanks for watching.